All right, in this video, we're going to look at solutions of inequalities. So we've looked at solutions of equations, a value that makes the equation true. So now we're going to talk about a solution to an inequality. So the values that make the inequality true. So a solution to an inequality is a value that makes the inequality true. An inequality can have more than one solution. The set of all solutions of an inequality is called the solution set. So now instead of dealing with a solution, we're dealing with a solution set. So a group of numbers that satisfy. Checking for solutions. Tell whether -2 is a solution of each inequality. So what we're looking for here is we're seeing how does the left side of the inequality compare to the right side of the inequality. Now we want to check the solution of -2. So what that means is we're going to replace y with -2. So this y, instead of saying y, is going to become -2. So -2 minus 5 greater than or equal to -6. So everything else will stay the same except for the variable that I replaced with the value. -2 take away 5 is -7. Greater than symbol stays, -6. Is -7 greater than -6? No, it's not. So this would be false, therefore not a solution. So -2 is not a solution for that inequality. Let's look at B. Again, I want to know, does the left side less than the right side? Is the left side less than the right side when y is -2? So again, we'll keep -5.5. I'll replace the y with -2. Now I'm putting it in parentheses for my kind of keeping that negative with the 2 and also reminding myself it's multiplication. Less than 14. -5.5 times -2. Negative times negative is positive. 5.5 times 2 is 11. So is 11 less than 14? That is true. 11 is less than 14. So this is a true statement. Therefore, it's a solution. Let's look at 3. We'll do the same thing. So tell whether -5 is a solution of the inequality. Why don't you go ahead and answer this one on your own? All right, so I'm going to put in -5 for x plus 12 is greater than 7. -5 plus 12 is 7 greater than 7. Is 7 greater than 7? That is no. That is false. Therefore, no. All right, let's try number 4. Why don't you go ahead and answer 4? 1 minus 2 times, again, p is -5. So I'm going to put -5 in. Less than or equal to -9. This is 1. -2 times -5 is a positive 10. Less than or equal to -9. 11 is less than or equal to -9. This is false. Therefore, no. And why don't we try 5? -5 divided by 2.5 is greater than or equal to -3. Negative divided by positive is negative, so I know my result's negative. 5 divided by 2.5 is 2. -2 is greater than or equal to 3. That is true. Therefore, yes, it's a solution. The second part of today is graphing an inequality. The graph of an inequality shows all of the solutions of an inequality on a number line. So we're going to represent our inequality on a number line. All right, so first we're going to look at our symbols. Our symbols are less than and greater than. These two symbols, when we graph, they're going to get a certain kind of circle on the graph at the boundary number, and that is going to be an open circle. It's an open circle because it's not equal to, so it doesn't include the value that we put that circle on. The less than or equal to and greater than or equal to, the equal to is the difference there. So that means it can include the value of our boundary number. So for these two symbols, we're actually going to fill that circle in, or we're going to shade it in. What we're doing by shading is we're saying, hey, include this number too. Everything that we shade and this number. Whereas with these two, we're saying everything we shade, but not that number specifically. So let's give this a shot, and the circles might make a little more sense here. So graph the inequality, which just means represent. Represent x is greater than 7. So here's how we're going to graph. We're going to draw a number line, and we're not going to put all of the numbers. We're going to put one specific number, and that specific number is the boundary point. The boundary point, or the number we are comparing to. Remember, an inequality is comparing. So in the middle here, I'm just going to put that number. So I'm going to put the 7. Once I put my boundary point, I'm going to put a circle. Regardless of what kind of symbol I have, I'm always going to have a circle. This is a greater than symbol. So if I look at my chart, the greater than symbol gets an open circle. So I'm not going to shade that in. I'm going to leave it as is. All right, so now we're going to read this statement again. X is greater than 7. Or we could read it as all the numbers greater than 7. So I want to think, where are my numbers greater than 7? On the left side of 7, so 5, 6, or on the right side of 7, 8, 9, 10, 11. The numbers greater than 7 are on the right side of my circle. So what I'm going to do is I'm just going to shade, or kind of squiggle over that side. And what that's saying is, here are the solutions. These numbers that I have shaded over here are the numbers that work here. An 8 is greater than 7. 9 is greater than 7. 100 would work because it's greater than 7. So we're representing all of our solutions. Let's look at B. B, again, I'm going to draw my number line, and I'm worried about that boundary point, -3. It's the only number I'm going to put on here with my circle. Now in this case, I have an equal to symbol, which means I get a filled in circle because I can be equal to -3. So if you think we're shading all of the numbers that work, we also want to shade -3. The numbers are greater than or equal to -3. So where are the numbers greater than -3? Again, on the right side of 3. C. I'm often asked if the direction the inequality points is the way we shade, and that's not the case. It might seem that way, but it's not always the case. For example, 5 is greater than or equal to m. 5 is greater than or equal to m. So again, I'm going to draw my boundary point, which is 5. And by now you might be thinking it's going to be a filled in circle. Now let's think about this. 5 is greater than or equal to all of my numbers. 5 is greater than or equal to all of my numbers, which means 5 is the highest number. 5 is the highest number, which means all of the numbers that 5 is greater than are over here. And that's where that whole idea of the symbol pointing the way you shade would not work. We could flip these all around and it might make a little more sense. So if I put the M first, I have to flip everything. I have to flip the symbol from a greater than to a less than, keep it in equals, and put my 5. So this might help us understand this a little more, is the numbers less than or equal to 5. Left of 5. And in our last one, here we're going to flip it around a little bit. It says write the inequality represented by the graph. So I'm going to start just with a variable. And I'm going to start with my boundary number. So in this problem, my boundary number is where my circle is, which is 1. The numbers here, are they less than or are they greater than 1? To the right would be greater. So I'm going to use a greater than symbol. And then the last thing is, should I have the equal to? In this case, no, because I have an open circle. So I'm going to stick with the greater than symbol. So X, the numbers are greater than 1, and that's what I have shaded here. Numbers greater than 1. Let's go ahead and look at B. Again, I'm going to start with a variable and my boundary point, -3. So what numbers are shaded compared to -3? Well, to the left would be less than. And I have a filled in circle this time, which means I include -3. So I include my equal to. And that is all about solution sets. So determining whether a number is a solution and how to graph the inequality.